Hello, let's continue our Sudoku adventure with Voyage to the East by Emphyrio. So this continues our Chinese Whispers theme week. If you're not sure what that is, definitely watch yesterday's video. But what are the rules for this puzzle? So we have normal 6x6 Sudoku rules. So in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these Chinese whispers in the grid. So they work kind of like German whispers, but do pay attention to the difference here. So adjacent digits on the line must differ by at most 2, not at least 2, at most 2. So what does that mean? That means if I put a 3 here, then this digit can only differ by at most 2. So it could be 1, 2, 3, 4, or 5. Obviously not 3 because it repeats in the row, but if Sudoku allowed it, it could be a 3, and then 6 is not allowed. So 6 is the only digit not allowed next to a 3, because 6 minus 3 is 3. That difference is not at most 2. It is, in fact, bigger than 2. All right, so that's Chinese whispers. We also have killer cages in the grid. Digits in a cage sum to the value in the top left. So this could be, for example, 3, 5, which adds to 8. All right, so those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. The eye definitely is pulled to these killer cages at the bottom that have Chinese whispers in them. So let's think about this. I want to think about the 8 cage first because I'm more familiar with them. There's basically, there are only 2 ways to add to 8 with unique digits. So we can do, first of all, we always have to have a 1. And the way you can prove that is if you exclude the 1, the minimum would be 2 plus 3 plus 4, which is 9. Just too big. So we have to include a 1. So there's always a 1. And then the remaining digits add to 7. So how do we add to 7? Well, 2, 5, or 3, 4. We can't do 1, 6 because the 1's already used. So this is either 1, 2, 5 or 1, 3, 4. And I can already see there's an issue with 1, 2, 5. The issue is 5 is too far from 2 and too far from 1. So wherever we put the 5, it's going to be next to a 1 or 2, and that's going to violate our Chinese whispers constraint because it can have a difference of 3 or 4. And we can only have a difference of 2. So this is actually going to be 1, 3, 4. That's the only way that works. I think the 13 cage is going to be similar. So we can do the opposite, basically. We can, well, not the opposite. It's kind of the same, but at the other end of the spectrum. So a 13 cage, first of all, must have a 6 in it. If it didn't have a 6, would be 5, 4, 3, which adds to 12. So we must have a 6. And then along with the 6, we're adding to 7 again. So we can't do 1, 6, because that would repeat the 6. So we're doing 2, 5, or we're doing 3, 4. And 2, 5 has the same problem that we had before, which is the, is it 2, 5? No, it's 3, 3, 4. Wait, are there problems with 2, 5, or 3? Sorry, I'm thinking about this weird. Right, it is 2, 5 that has the problem. Sorry, I got confused. The problem is with the 2. I was thinking the problem would be the 6, and I got confused. The problem is with the 2. The 2 would be next to a 5 or a 6. Which would be a difference of 3 or 4, so that doesn't work. So we have to do 3, 4, 6. All right, cool. Now, I think we can do a little bit better than that because the 3 and the 6 can't be next to each other. They have a difference of 3. So the 4 has to go in between them. So the 4 goes here, and then that makes this a 4, and then 4 is too far from 1, so that makes that 3 and 1. That makes this 6 and 3. And that resolves. I think this one we could have done the same where we put the 3 here because the 4 and 1 had to be separated. Cool. Well, that's good progress. This is a 2, 5 pair. The remaining cells in this box, or the remaining cells are 2, 5, and 6 here, and the remaining are 2, 5, and 1 here. All right. So I'm thinking about these lines here that see 3, 4 now. Even if we ignore this one here, just taking the difference between these two into account, they can't leap over the 3, 4, right? If I put a 2 here, it can only be next to a 1 because I can't do 3 or 4 already in the column, and 5 is too far away already. So we're never leaping over the 3, 4. So this is either a 1, 2 or a 5, 6, but it's not something like 2, 5 or 1, 6. So, I mean, that looks like the same penciling. It's also over here. Looks like the same penciling as what's left in the column anyway, but we'll have to remember that it's only 1, 2 or only 5, 6. So let's take one case at a time. If it was 1, 2, what would this be? Well, biggest thing we can be here is 2, and therefore the biggest thing we can be here is 4, and 1 and 2 are used. So this would be 3 or 4 only. And I think 5, 6 does the same thing. because the smallest we can be is 5, which means the smallest we can be is 3, and the 5, 6 are used. So this would be 3, 4 also. So no matter what this ends up being, this becomes a 3, 4 pair. Okay. All right, so one thing I'm seeing about this 8 cage is, you can't put a 4 in an 8 cage. And actually in 6x6, you can't put a 1 in an 8 cage either, because it would be 1, 7. So there's 2 digits we can't put in it, and we don't know where those digits go in the column yet. So 1 and 4 actually go here and here, because it's the only 2 places they can go, because they can't go in the 8 cage and they're not down here. So 1 and 4 go here and here, and this 3, 4 pair tells us the order. So this is actually not 1, 2. This is 5, 6. We can't resolve this yet. This is not 1. That's not 2. Okay, so then this 6, what can't we put in it? We can't put a 6 or a 3 in it. So again, this can't be 3 because of the 3, 4. So this is the 6 and this is the 3, because they're not down there. It's kind of neat how that worked out. So this is 2 and 1. And then this 6 makes this 5 and 6. I think, yeah, 3, 4 works either way. Okay, so what do we do next? Well, this column needs a 3. We don't know where 3 goes yet. It definitely goes in this 8 cage, though. So the 8 cage has to be 3, 5, because it must have a 3, and we know the order because of that 5. That gives us the 4 and the 3. So that gives us the 2 and the 6 and the 5, the 5. All right. Is there something similar here? 1, 2, 3. Yeah, we need a 4 in this column, so this has to be 2, 4. And we know the order because of that 2. All right, cool. That's a 5. That's a 2. This is a 1, 2 pair. I don't think that's resolved. Oh, it is resolved. Sorry, somehow missed that. And then this is 3 and 6, which we do know the order. This is 1 and 4. We know the order. And then 5 and 6 go like that, and we're done. Very nice. Well, cool puzzle, Emphyrio. I liked I liked all the interactions here. How the 8 and the 13 basically ended up the same logic, just sort of on opposite ends. That was a neat demonstration of how that can work, and how the line kind of restricted us to only one of the viable options for how to add to 8 and 13. And then I liked how these lines worked, where we ended up with this 3, 4 pair. And you really utilize that 3, 4 pair well by making these 8 and 6 cages. So yeah, I really liked that. It flowed pretty well. Not too hard to spot each deduction as they came in. Probably the hardest spot was just noticing that 1 and 4 and 3 and 6 had to go in specific places in these columns, but I don't think it's that hard to see that. So, because the 8 cage and 6 cage, you're going to be thinking about what can't go in them. Even if you just penciled it, you'd probably see it. Anyway, very cool puzzle. I enjoyed that a lot. And of course, if you enjoyed this, then why not leave a like, subscribe, and a kind comment below.